Hello, I'm Min, and today I'll be going over how to do number 3 of the Chapter 1 free response questions. So, starting off, the problem it gives us is the amount of money raised during a fundraising campaign is modeled by the function f, defined above, where ft is measured in United States dollars and t the time and day since the campaign began. So in this problem, it gives us a function here, which has two parts to it. And from that, we're supposed to answer the questions A, B, and C. So the first question asks for the limit of the function ft and explain what the limit means in the context of the problem. So in my work, I chose to answer it by first writing out what the limit was, so just like rewriting the problem, the value of the function ft, and also the constraints it has on each function. And from there, I knew that t was approaching infinity, so that I would have to substitute values that are increasing all the way to infinity for t, so that I can see what value ft would approach as t goes to infinity. So basically, I just made it so that the t would increase in gradual intervals, like first plugging in 10 for t, then 100, then 1,000, and then just getting the values from that and making a conclusion from it. So at first, for t equals 10, it was 533.3 repeating. Then for t equals 100, it was 783.3 repeating. And finally, for t equals 1,000, it was 798.395. So what I was able to conclude from that was that as t approaches infinity, f of t would approach 800. How I got there was that seeing my values each time I plugged in a new value for t would get ever so close to 800 but never actually touch it. See, for t equals 100, it was 783, and t equals 1,000 is 798. Even though 1,000 is like 10 times greater than 100, there was only ever an increase in like 15 USD. So that is very obviously a sign that f of t is only ever going to approach 800 and never actually surpass it. So that was how I was able to get my answer for A. And in the context of this problem, it means that our limit value of 800 means that no matter how many days pass since the start of the campaign, the max amount of money that can be raised in USD will be just short of 800 and will never reach it. So yeah, that's how to find the limit and also how to interpret it, because the limit is saying that it will only ever that f of t will only ever approach 800 but never actually reach it, even if x were to go on to infinity. And so back to B, it's asking, is the function f continuous at t equals 7? Justify your answer. So I chose to answer this by plugging in the value 7 for t for both of the equations. So the equations of basically these two equations that comprise of ft as a whole, I chose to plug in 7 for both t values. So first off, the first equation, if 7 were substituted for t, would be equal to 254, because 2 to the t power plus 1 minus 2 is equal to 2 to the 8th minus 2, which would be 254. And also the second function, which was 800t minus 4,800 over t minus 4, would equal to 800 times 7 minus 4,800 over 7 minus 4. And so that would roughly equal to 266.6666 repeating. And from that, I was able to conclude that f is not continuous at t is equal to 7. How I know that is that because after substituting in 7 for both functions, they were not equal to the same value. And you may be asking, why does that mean they're not continuous at 7? Well, in order to be continuous at a certain point, it means that both functions would have to equal the same y value at the given x value. So in this case, the x value is 7. And as we can see from the restraints put on the function, that the first function would end right before 7. So like since t is less than 7 and not equal to, it end at like 6.999 or whatever. But the second function like picks up right after t is equal to 7 and t is greater than or equal to 7. So what this means is that in order for the entire function to be continuous, t would have to be, the value of 7 would have to fit into both functions and equal the same y value, for where the first function to end would be right exactly where the second function picks up. So like, for example, if 7 were substituted in for t for this equation, and it would equal, let's say, like 20 or something, then if 7 were substituted for this equation, this should also equal to 20, so that it can pick up right after where this left off, so that it can be continuous and there wouldn't be any breaks in the graph. So by substituting 7 for both functions and getting values from it, you can conclude whether the graph is continuous or not by seeing if they're the same value. And since in this case they weren't, I concluded that it was not continuous at 7. And moving on, finally, to question C. The amount of money raised during a competing fundraising campaign is modeled by the function m, defined by mt is equal to 240, whatever this function is, where mt is measured in United States dollars and t is the time and days since that campaign began. According to this model, is there a time t for 0 is less than or equal to t is less than or equal to 2, at which the amount of money raised is $10. Justify your answer. So although this problem might seem a bit scary at first, it's very, once you start, you'll see it's very familiar. So essentially this is just plugging in a value for y and solving for it. So in this case, our y is 10, and in the function y is equal to mt. So you can just substitute mt for 10. And you already have the function of the entire, well, you already have like the function of the competing fundraising campaign. So the question is essentially asking you for what t value would the total amount of money raised equal to 10. So you're just solving for t, and that's a bit complicated but not hard. So once you substitute 10 for mt, you can start solving. You do 10 is equal to the function 240 times 2t minus 1 over 2t plus 36. And so you first multiply out the parentheses at the top, so you distribute 240 to all of the parentheses. So it'd be 240 times 2t minus 240. And from there you can multiply out this division, like this fraction basically. So you can move this 2t plus 36 over to the left side by multiplying both sides by 2t to the 36. And from there you can also distribute the 10 to the parentheses 2t plus 36. So now you have 10 times 2t plus 360. And then you basically combine like terms. you subtract 360 from here, move it over to the right, and you subtract 240 times 2t, move it over to the left. And now you have similar amounts on the same side. And from now you can basically combine like terms, which is negative 240 minus 360 is equal to negative 600. And here you can just subtract 240 from the 10 and you'll get negative 230 times 2t. I think this accidentally erased it here, but that's my bad, sorry. But now you can divide both sides by the negative 230, and so now you'll have 2t is equal to 600 over 230, which simplifies into 60 over 23. And now this just becomes a basic log problem, where you need to log both sides in order to get t by itself. So you log 2 to the power of t, then you log 60 over 23. So you'll get t is equal to log of 260 over 23. Log 60 over 23. And so then you can simplify it further. You can do log of 4 times 15 over 23, which simplifies down to log 4 plus log 15 over 23. And we all know that log 2 of 4 is equal to 2. So we can simplify it to 2 plus log 15 over 23. And then the rules of logging a fraction would be the log of the numerator minus the log of the denominator. And you'll get 2 plus negative 0.616671. And so your time will become, the final time you get would be 1.38333, which roughly simplifies into, roughly rounds down to 1.383 days. So after doing all this math, you're able to conclude that the amount of days it'll take for $10 to be raised is roughly 1.383 days. So that's how you solve C. You basically just do basic math, you substitute 10 for the MT, and you do all the math that gets you to the time, solving for the time, which in this case is 1.383 days. And that is the amount of days it would take for the entire competing fund to raise $10. And yeah, that's how you do the number 3 for the FRQs, chapter 1. Thank you.